Hi, I'm Mr. B. During this lesson, I will use a laboratory assignment to explain the differences between a physical change and a chemical change. During a physical change, the chemical and physical properties of a substance will not change. However, during a chemical change, the chemical and physical properties of a substance will change. So let's go to the laboratory assignment to see the differences between physical and chemical changes.
Pre-lab discussion. Chemistry is the study of matter and the changes that it undergoes. These changes can be broken down into several pre-lab discussion. Chemistry is the study of matter and the changes it undergoes. These changes can be broken down into two classes: physical changes and chemical changes. In a physical change, one or more physical properties of a substance are altered. Examples of such physical properties include size, shape, color, and physical phase. Grinding, melting, dissolving, and evaporating are all physical changes. No new substance or substances are formed as a result of a physical change. A chemical change results in the formation of one or more new substances. These new substances differ in chemical properties and composition from the original substance. Rusting of iron and burning of paper are two examples of a chemical change. This experiment will help you understand the difference between physical and chemical changes and to recognize each type of change when it occurs. The purpose of the lab is to recognize and distinguish between chemical and physical changes. Now for the procedure. Note and record all observations in your data table. Place a small amount of wax from a birthday candle into a test tube. Heat gently over a burner flame until the wax melts completely. Allow the sample to cool. Next, light the candle and secure it to a glass square. And allow it to burn until it extinguishes itself. Proceed with the rest of the experiment while the candle burns. Number 2, tear a piece of paper about 5 centimeters by 10 centimeters into small pieces. Set a watch glass on an insulated square and place the piece of paper on the glass. Ignite the paper with a match and allow it to burn. Number 3, add a microspatula of NaCl sodium chloride to a small quantity of water. Shake the contents of the tube. Next, use a dropper to add about 10 drops of AgNO3, silver nitrate, to the sodium chloride water mixture. Obtain a piece of magnesium ribbon. This is number 4. Obtain a piece of magnesium ribbon about 5 centimeters long and tear it into 1 centimeter pieces. Place 2 of the pieces into a test tube and add a few drops of 6 molar HCl. Use a mortar and pestle to grind several crystals of copper 2 sulfate pentahydrate into a uniform powder. Place 1 microspatula of the powder into a test tube. Heat gently over a burner flame for 5 minutes. Allow the sample to cool and then add a few drops of water. Now before I do that, let's go back to the melted wax. Melting the wax is a physical change because wax is still in the test tube. If it had been a chemical change, the wax would have become something else. But since this is still wax from the birthday candle, that was definitely a physical change. Dissolving sodium chloride in water. When you dissolve something in water, the properties of the substance does not change. It just simply appears to disappear in the water. But by adding another chemical, such as silver nitrate, to the water-salt mixture, I formed a new compound. This compound is called silver chloride. The reason that you can actually see the silver chloride in the water is because silver chloride doesn't dissolve in water. It is insoluble. And you can see on the bottom the silver chloride precipitate. When I added acid to the magnesium, it bubbled violently. That's because it's a chemical change. Remember, in a chemical change, you always get something different. So by adding acid to the magnesium actually reacted with the acid to form a new compound. The new compound is magnesium chloride and hydrogen gas. Grinding the copper 2 sulfate into a powder was a physical change. In a physical change, you still have the original substance available. It's only in a different form. What was a crystal now is a powder, but it's still copper 2 sulfate. Because copper 2 sulfate is a hydrated compound, hydrate means that water is in the molecular structure of copper 2 sulfate. Heating it will drive the water off of the compound or out of the compound, leaving a white substance behind. This white substance is simply copper 2 sulfate. However, if I add water to this compound now as the lab indicates. It said add a few drops of water to the compound. Then the water turns blue, meaning that the copper 2 sulfate is being hydrated again. So this type of change represents a physical change because we could get the original copper 2 sulfate back. In the next step, we'll use a laboratory balance to measure out 0.5 grams of iron filings into a test tube. So without a balance, I'm going to say that this is about 0.5 grams. Then I'm supposed to add 0.5 grams of sulfur powder to another test tube. And I'm going to say that that's about 0.5 grams. Okay? Then I'm supposed to test each sample with a magnet. So you see a magnet is attracted to the iron. A magnet is not attracted to the sulfur. Then it says mix the two samples thoroughly in a test tube. Then it says run the magnet along the bottom and the sides of the test tube. So you see that the magnet is definitely attracted to the iron, but not attracted to the sulfur. Actually, I can separate the iron from the sulfur with the magnet. In the final step, we're asked to heat this iron-sulfur mixture in the burner flame for several minutes until the mixture glows. Then run a magnet along the test tube again. So I think my sample is glowing now. Now I'm going to let it cool. And now I'm going to run my magnet along the bottom of the sample. And you can see that very little iron, only the iron that didn't react, is actually being attracted to the magnet. The rest of the iron is now in a compound called iron 2 sulfide. This reaction represents a chemical change.
So, as you've seen, changes such as grinding, tearing, melting, and dissolving are all forms of physical changes, whereas a change that involves a reaction, where a gas is produced, for example, is definitely a chemical change. That sums up my lesson on physical and chemical changes. Thanks for watching.